In order to finish static attack 64-bit application with a small buffer size, in this case the buffer size is just 10 bytes. The first step is we need to figure out the stack frame pointer RPP, and then the distance between this stack frame pointer to the buffer size. Here we call this distance is the offset. Now let's use the GDB to check the values. We need to set the breakpoint at function BOF here and then run. We can check the offsets by this commands. RPP minus buffer. Here we use to show the decimal value. And then we use the command next to run to the string copy function. Yep, here we see that the offset is 10 bytes, and then we can show the RPP address. This is the DD80 address for the last 4 bytes, and then the rest of the buffer. DD96. Now let's just copy the address into the exploit function. And then the buffer. Here we will set the return address. The offset for the return address, this would be the distance shown here plus 8 bytes for 60-bit program. And then we need to choose the return address, the next return address. In this case, I use this offset here. It will zoom to nearly the end of the file because we just have 517 bytes for the buffer attack. So we can zoom to this offset. This is the middle of the NURBS instructions, and in my case, when we jump to this offset, this is the safe zoom. And then we set the address of the return, the length of the return address is 8 bytes here. Now let's do the attacks. Python 3 exploit 64. Yeah, we generate the bad file. You can see the bad file. And then let's just L4. Yep, we successfully get the shell here. Let's check the ID here. Because I insert the binary instruction for the set UID, so we can get the root account here.